Okay, this is Trig, lesson 4.1, homework help. Question number 1 says, a triangle that does not contain a right angle is called an oblique triangle, and solving the triangle means finding the length of its sides and its angles. Number 2, complete the sentence below. If A, B, and C are the measures of the angles of the triangle, A, B, and C are the legs, then the law of sine states that. And the law of sines is A over sine A, B over sine B equals C over sine C. So this is this one. Number 3. We can always use the law of sines to find the missing parts of triangles in which one side and two angles are known. Question 4, true or false? A triangle in which two sides and an angle opposite of them are given always results in at least one triangle. This statement is false because oblique triangles which two sides and an angle are given can result in the ambiguous case. So it could be one triangle, two triangles, or no triangle. If two sides A and B and the included angle C are known, then the area of the triangle is found by using this area formula, 1/2 AB times sine C. So it's 1/2 the length of the two legs and then the sine of the angle that is not opposite either of those legs. Number 6, solve the triangle. So here's the law of sines. A over sine A equals C over sine C equals B over sine B. Here's our picture. This is A, this is C. We can find angle B by the fact that we know a triangle has 180 degrees. And we know that side A is 10. So I set up my ratio, and I'm going to find side C first. So 10 over sine of 34 equals C over sine of 92. Cross products. I multiply both sides by the sine of 92. And then I come back through and divide by the sine of 34. So this is what I need to put in my calculator to find the answer. So I want you to be sure when you turn your calculator on, press mode, make sure you are in degree mode. Okay, so we're in degree mode. It says it right here. And then we'll type our problem in. Sine of 92 times 10 divided by sine of 34. And I get 17.87. It says round it to the nearest tenth. So this is 17.9. Now we already figured angle B as 54 degrees. So now the only thing we have left to do is find side B. So we set up a very similar ratio. 10 over sine 34 equals B over sine 54. We'll go through the process again and we end up with 14.5. Question number 7. It says solve the following triangle. The first thing I did was I found my missing angle by using the fact that triangle has 180 degrees, so I got this to be 90. And then I set up A over sine A equals B over sine B. I used my cross products and I solved for the missing A and I got 3.8. I set the same ratio up over here to find B and I got 10.3. Number 8, very similar. Find the missing angle. Set your ratios up, solve, round to the nearest tenth. Number 9, same thing. Draw your picture, label your parts. So, the law of sines is just used over and over. 10, same thing on 10. 11, two sides and an angle are given. So I'll draw my picture. A is 80 and side A is 4. And B, the side of B is 1. So I set this up and I have sine of 80 times 1. And then I'm going to divide by 4. And this is the sine of b. The sine of b is the missing part. So this is what I get for the sine of b. To actually find angle b, I have to press second sine, and then I'm just going to copy and paste that number. And I get 14.2. It says round to the nearest degree, so that's 14 degrees. Well, once you find b and you know a, you can subtract from 180 to find c, and then you can set this up and use the same process we've been using to find this missing side. Now, be careful. If you had done that work and the number that you'd got for the sine was bigger than 1, it would have been no triangle, because that sine and cosine have to be less than 1. Okay, number 12. Draw my picture. A is 67, side A is 15, side C is 7.8. So the first thing I'm going to do is try to find this angle C. I set up A over sine A equals C over sine C. So 15 over sine of 67 equals 7.8 over sine C. 15 times the sine of C is 7.8 times the sine of 67. I'm going to divide by 15 here. So this is what I get for the sine of C. I'll type that in. It is 7.8 times the sine of 67 divided by 15. That's the sine of C. And it's okay for sine to be that value. It's not outside of its normal range. So I'm going to use inverse sine, find my angle, round to the nearest degree, 29 degrees. Well, now that I know that that's 29 and the other angle is 67, I can find the missing angle, and then I can set up another ratio to find the missing side. Number 13, draw my triangle. A is 100, side A is 42.9, side C is 36. So I set my ratios up. Very similar to the last problem, I find the sine of C. I use second sine to find the angle, and the angle is 56. So angle C is 56. Then I subtract the two angles that I know from 180, and I find the other angle is 24. Set up your ratio, solve like we've been doing to find the missing side. Number 14. A is 80, side A is 12, side B is 13. I set my ratio. My missing value is the sine of B. I solve for the sine of B, and I get this number. It's larger than 1. That is impossible. So this is one of the situations where there are no possible solutions for this triangle. 15 asks you to find the area. Here are the 3 possible versions of the area formula that you might have to use. In this one, you're going to use the third one, because you know side B and you know side C and you know angle A. So 1/2 of 25 times 35 times the sine of 32. I put that in my calculator, round to the nearest whole number. I got 213. Same thing on 16. Use the appropriate formula. My answer here was 7. 17, same thing. Use the appropriate formula. 18, find H. So I have 2 triangles together. They tell me that this is 21. They tell me this is 73. So I subtract 73 from 180 because this angle will be 107. Once I know this angle, then I can subtract 107 and 21 from 180, and I get 52 for this angle at the top. That's a 2. It's hard to see. So it's 52 degrees. So now I can set up my ratios to find my missing side, because what I'm looking for is this side right here. I need this side because it is a member of both triangles. So I have C over sine C, which is 386 over sine of 52, equals A over sine A, which is A over 21. Solve appropriately, and I find that side A is 175.5. That's the hypotenuse. It's across from the 90-degree angle, so I'm going to set up another ratio for this triangle. 175.5 over the sine of 90 is equal to h over the sine of 73. Solve that one like we've been solving. Round to the nearest tenth. I got 167.8. Number 19. Use the given measurements to solve the triangle. Round the lengths to the nearest tenth and the angle measured to the nearest degree. So I have theta and 2 theta. So I start out with 300 over the sine of 2 theta equals 200 over the sine of theta. As I multiply cross products, I have 300 times the sine of theta equals 200 times the sine of 2 theta. I'm going to go to my reference sheet and I'm going to replace sine of 2 theta with its identity. So this becomes 300 times the sine of theta equals 200 times 2 sine theta cosine theta. Now the next step is simply just to multiply right here. So I have 300 times the sine of theta equals 400 times the sine of theta times cosine theta. Now I'm going to divide both signs and they're going to go away. And then I'm going to have 300 is equal to 400 cosine theta. I'm going to divide by 400. So I get cosine theta is 3/4. So I'm going to go to my calculator, second cosine, 3/4. And I got 41.4. And it says round to the nearest degree, which is 41 degrees. So theta is 41 degrees. Now, I'm going to double what's on my calculator, and I'm going to round this to the nearest degree, which is 83 degrees. And then from there, I can subtract from 180, and I find that the other missing angle is 56. The length of C, you need to set up C over the sine of 56 is equal to 200 over the sine of 41. Or you could use 300 in the sine of 83. Set up a ratio and solve, and we find the length of C to be 250. Number 20. A tower is leaning 84.7 degrees. The figure shows that 166 feet from the base of the tower, the angle of elevation is 50.8. Find the distance from the base to the top of the tower. So we're looking for this distance. So I'm going to find my missing angle, and it turns out to be 44.5. So I can now set up my ratio. 166 over the sine of 44.5 is equal to B over the sine of 50.8. And I can solve, and I see that the length that I'm looking for is 184. 21, it says a pine tree is growing on a hillside that makes a 76-degree angle with the hill. From a point 84 feet up the hill, the angle of elevation is 62 and the angle of depression is 22. Well, the first thing I did was I combined those two angles to find that this angle, angle C, is 84 degrees. Angle C is 84 degrees. This distance, which is distance B, is 84 feet. I can now find angle B, and it's 20 degrees. So I will set up 84 over the sine of 20 is equal to C over the sine of 84. Solve, and I'll get 244.3. 22. Trees in the local park are hundreds of feet tall. The height of one of these trees is represented by H. Find H. Well, the first thing I did was I subtracted 25 from 180, and I got 155 for this angle. It's very hard to see. It's written right here. And then I could find that this angle was 10. So now I'm set up for 425 is across from the 10. So 425 over the sine of 10 is equal to A over the sine of 15. Once I find A, I can use it in this triangle to find H. So I solve and I find A, and that value over the sine of 90, A over the sine of 90, is equal to H over the sine of 25. And from there I can find that H is 267.7 feet. It also asks you to find this first length A, and that was 633.5.